All right, let's see what we got here. I believe everything is working. Okay. Believe everything. Okay. All right. Good afternoon, everybody. This is basic stats, VSTHUM 800, and today we're gonna go over the syllabus, and then we continue with chapter 1. Let me check. Okay, so everything seems to be okay. All right. So what I'm going to do every week, I'm going to cover a chapter and upload it, and you can just watch it and let me know if you have any question. The best way to communicate with me is to email me. Occasionally, I will have the session synchronous like this one, and then but most of the time I pre-record my session asynchronous. So let's briefly go over the syllabus. Syllabus is in the Blackboard. You can read every words and page of it. Okay. But I will just cover the highlights of the syllabus so you will understand. The first page or two are just the instruction regarding how to use the Blackboard. And then again, your textbook. I have one or two textbook. Either one of them is acceptable. And it's important to have the textbook because you will have assignments like homework. I know that, you probably say this is doctoral level course and homework, it doesn't sound good, but this is how I know that you've been working by doing those homework. And you will get extra points when you complete the homework. And it's all in there, explained. If you have any question, once again, let me know, please. If you need to talk to me via Blackboard, collaborate, there is my office hours. You can on Tuesday, Wednesday, Thursday after 5 p.m. So let me know in advance, please. Let's go down, see what else is there. The course objective, you can read them. The main purpose of taking this course is to prepare for your doctoral dissertation. And one of my goals for you guys is to start thinking about your hypothesis. Even though this is not a research class, it's statistics, but once we talk about all these procedures, statistical procedures, you would know, you will have probably some idea about how to conduct the research, how to implement your knowledge into your quantitative research. So these are some suggested texts. The first one, or the one that I will be using, I go by when I talk about the pages, is this one, David C. Howe. Okay. You can get a previous version or the newer. It doesn't matter. Any of them will do. The grading scale. So briefly, for the midterm, you have to do 5 quizzes. Basically, every chapter that I cover, like the one I'm going to cover tonight, you will have a quiz on it. All the quizzes are in Blackboard. If you go there, which you know, I'm sure you're there now, you will see it says quizzes for the midterm and quizzes for the final. And then you see the SPSS for assignments for the midterm and SPSS assignments for the final. You must have a copy of SPSS in your laptop to do these SPSS assignments. You may contact the AU and let them know that you're taking this course, and they give you the instruction and send you the link to download a copy of SPSS. You may contact Rudy, IT, Rudy, or Louis, if you call them. For the second half of the semester, of course, so you have 5 quizzes for the midterm and 5 SPSS assignments. They are very important. Again, you learn test the statistics manually, do the calculation, and then you also, in your SPSS assignments, learn how to use the SPSS to do the calculation. So after you're done with these, you do the midterm exam, which is just really, it's just another quiz. It's just larger. The midterm exam consists of all those quizzes, those 5 quizzes for the midterm. And the second half of semester will be pretty much identical with the first half. You will have 5 quizzes for the second half and 5 SPSS assignments, and then final exam once you're done with those. So please stay on top of everything. You don't want the work accumulate and you just stay behind. The best is to, like, for example, tonight I will cover chapter 1, and you will have to take quiz 1 and do your SPSS assignment. If you can do it by next week, will be great, because next week you will have another session, preferably asynchronous, And then again, please let me know if you have any question or concern. So those are pretty much highlight of the course. With further delay, okay, there's a schedule and assignments. As you can see today, week 1 says that we have a lecture, cover the syllabus, and we should be here for a couple hours. And then these are stuff we're going to cover. And then you can see the color right there is pink, where it says week 1, 113. That indicator of synchronous. That means, it'll be live. But again, based on the previous session, I understand that most students are professionals. They work, they have a professional job, and they're unable to attend. If it's convenience for one, it's not convenience for the other. Therefore, I am recording every session, and the recorded session will be in Blackboard under the Collaborate. The instructions are here in the syllabus. Also, I will have a copy of them. I will put them in YouTube so you can have the link and have access to them. And again, week 2, which is the next week, we're gonna have asynchronous, and you can see the stuff that we cover. And week 3 with the dates and everything. Let me know if you see any error, please, so I can fix it regarding those dates and assignments. We try to go by these dates, but sometimes it's difficult. And then on week 8, we have a midterm exam. Hopefully by then you completed all your 5 quizzes and 5 SPSS assignments. And after that, we're halfway there, and we start the second half of the semester with week 9 and those things that we need to do. And then again, after you're done with your second half of the semester quizzes and assignments, on week 15, you will have the final exam. And that's pretty much it. Okay, so these are some extra instruction. Please read them all the way. It tells you like how to find your assignments in Blackboard. So that's for the syllabus. So let's just start. Okay, let's see. We're gonna pull up the first. I'm gonna pull up the first PowerPoint. Right. All right, let's go for the PowerPoint number 1. All the PowerPoints are in Blackboard, so we're going to start with the first one. PowerPoint 1 covers chapter 1 and 2. So let's see. Again, most of these PowerPoints are self-explanatory, and I'm not going to cover every one of them, but it'll be a great idea if you read them, read every one of those slides. Okay. Let's double check. Okay. All right, so we're gonna start with your first PowerPoint. This is basic stats. VSTHUM 800. It's about basic concepts and scientific methods, things that you need to know. So again, I will skip some of those PowerPoint, but please read them, especially if you haven't have any research method class, because again, this course is designed to help you complete your doctoral dissertation. In order to do so, you need to be knowledgeable about research methods and statistics. So they go hand in hand. Chapter 1 is about basic concepts, and chapter 2 is about describing and exploring data. Data are numeric information. Working with numbers, that's what it is. And briefly, I'm going to talk about your research, give you some idea to start thinking about your doctoral dissertation topic. So again, I've been teaching this for 20 years, stats and research in different universities, especially Albizio for 20 years. And I know there's a lot of students, they select a topic that is doable, they think is doable, but it's not doable in terms of doing it in 1 year or so. So doable means being able to complete your dissertation in 1 year, not 10 years. So you don't want to get into uncharted territory. You need to stick with the area that you're good at, you're familiar. Let's say, for example, you work with the ADHD children. So it's good if you can stick with that. Or autistic children, or you have some kind of managerial job and you wanted to know something about the employees' optimism, things like that. Anyway, so you need to know, is your dissertation. You describe your expectation. What are you expecting yourself to do? Then you start collecting information regarding your topic. Then you become knowledgeable. Like I said, if you're working, then I'm sure you are knowledgeable on a work that you're doing. Develop and elaborate research question. Then ask yourself that what is it that you're trying to do or measure? That gives you a theory. Again, theory is a theory. People say, oh, I have a theory. Theory could be right or wrong. So the only way to find out is to convert your theory to hypothesis, which people say is like a statement, educated statement. So that's your research topic. And it's about testing your hypothesis. Once you formulate that hypothesis, which is your research topic, doctoral dissertation topic, then you're going to tested, see if you're right or not. So it's all about rejecting the null or retain the null. And we will talk about that. That's the statistic part. When we talk about reject the null, it means that null says, though, this is not likely, but we as a researcher, H1, we think so otherwise. Yeah, we believe that it is so. So again, the only way to prove this argument is to use the statistical formula and follow the hypothesis testing and decide, come out with the final answer. So it's good, you know, I have many examples in this regard about research, so I encourage you to read them. And then we're going to start with stats, like what is a statistics? A statistic in general is a set of methods and rules, a set of statistical procedures, we call them, for organizing, summarizing, and interpreting information. That information, the numeric information mostly, which we call data. So and to do so, there are many types of test statistic: t-test, ANOVA, ANCOVA, MANOVA, correlation, regression, different type of t-test, different types of z-score, and you need to become familiar with these statistical procedure so you select the one that is best for your topic. In terms of so again, when you do this, first thing you need to know is you need to know what is sample and what is population. I have my own analogy here. It's not about memorizing statistics, research, nothing to memorize. It's all about understanding how to conduct this research that that we call dissertation. So sample and population, we think that the population is set of all individuals of interest for a particular study. So if you decided to use a sample from, let's say, AU, Albizio University, Albizio University is your population, and you will have a sample. Sample will be a subset of population. And then again, it's not about memorizing the definition. It's about understanding what is sample, what is population. And we use that mostly, again, for inferential statistics. And we will talk about stats, inferential and descriptive stats. So again, this is my analogy. And the reason we're doing it is because this right here, you're looking at the large pizza. And assume it's very large. So large that no matter how hungry you are, you can't eat it. And that's what it's all about. It's not about eating the whole pizza or the whole population, work with the whole population. It's about taking a sample and decide, make a decision about the population. Let's say this pizza have all kinds of topics, and you take a slice, which is your sample, and you have a bite or two, and you know that you like it or not. Otherwise, you can tell that it's too saucy, too doughy, or whatever is wrong with it. That sample would tell us. So that's why we only take a sample from a population. Let's assume that AU has a population of 1,000 students. You don't have to work with all those 1,000 students. You will have, let's say, 200, a sample of 200 students, and you work with them, and whatever information you get applies to entire population. of AU students. This is called inferential statistics. Also can be descriptive. It depends on what are you looking for. The difference between the pizza and that what you're looking at, this is a normal distribution, and those little squares are different samples. You can take unlimited samples from a population. Once again, if that distribution is AU, I can take a sample, and the next person, Joe, John, Jane, they all can take a sample. The reason we can take unlimited sample is because all those samples will go back. Like if I have a sample of 500 students, then you would think there's only 500 left. No, those 500 will go back. I use them in my research and they're still there. So the population will still be 1,000 for the next person, for the next researchers and beyond. But unfortunately, it's not true for the pizza. So once you finish those slides or samples, the slices of sample slices of pizza, then you're done. But you never be done with the population. It's always there, and you can take unlimited sample as many times as you want to. So that's the description of sample and population, and here it is in detail. And in terms of so that's our description. So you can see there's a population, bunch of people. You take a sample and you will find out something about it, and then you apply that to the population. Infer means draw conclusion from your sample. That's why we call it inferential statistics, and we'll talk about it. Tonight we're going to talk about descriptive statistics. I call them little guys. And once we're done, we finish the descriptive statistics, like mean, median, mode, scale of measurements and all that, standard deviation, variance. Then we're going to move to the statistical test, or test the statistics. Like, again, I call them big guy, like a, t-test, z-score, ANOVA, correlation, regression. And just to show you the picture of hypothesis testing that we measure. H1 is us, the researcher, when we develop a hypothesis. H0 or H0 is the null. Null always says, no, I don't think so. If we say that there's a correlation between consumption of sugar and hyperactivity, null says, I don't think so, no. Or if we say there's a positive correlation, null says, no, there is not correlation, or if any, will be negative, exactly opposite of what we're saying. So we have to test our hypothesis, follow the 4 steps to reject the null and say, hey, so we got something. We'll talk about this in a few weeks, after we get rid of these descriptive statistics. Make sure you understand those measures of central tendencies and mean, median, mode, and beyond. So again, this is all about research, all these slides that I'm passing. So it's good to read them. And again, the distribution that we're going to work with in research is, or mostly in stats, it's called normal distribution, or bell-shaped or symmetrical distribution. This is where you're looking at the at the IQ distribution in population, with the 100 in the middle is mean, and then those fixed distances away from it, above or below the mean, go to the right is above, go to the left is below, are standard deviations. Fixed distances are called standard deviation from mean. So you square those distances, like the standard deviation is 15 here, there's 15 points from each, these numbers or these standard deviations are 15 points from each other. So the variance is just the square of that, square the 15. So again, there are many other distribution, normal distribution, standardized distribution, or standardized test. In psychology, we have many standardized tests. And if we use those, then it's better to use a test of statistics that matches that standardized test, like Z-score, for example, Z-score. If you don't have a standardized test, then you got to use t-test. We're going to talk about all these in coming up. So just briefly, I just want to mention that the last thing I'm going to say about your research hypothesis, you got to be careful about selecting your hypothesis, because words are very important in your hypothesis or in doctoral dissertation topic. For example, what you see in the next 4 slides are coming, they all really, that you only have 2 variables, and high cholesterol and heart attack. These 2 are your variable that you can measure. But the way you say it, it calls for different types of research. For example, if you say high cholesterol may cause heart attack, that's causation, that's cause and effect. That is experimental research. There's experimental research, there's non-experimental research. There are many different types of non-experimental research and many types of experimental research that you need to know all those and need to learn them in your research methods if you haven't. Once again, if I just change that cause to related, heart attack is related to, now you're using non-experimental research, in this case correlational, relationship, association between heart attack and correlation. One word, and they totally different types of research. So you need to know what you're getting in. And then again, there's a combination of both, that there is a way to measure it. It's called using a special software. It's called structural equational modeling. And there are the other different types, like there's a meta-analysis, which requires another software. And then you can say a meta-analytic study of heart attack and high cholesterol, which what this does, it combines all the research related to heart attack and high cholesterol, and it gives you the final answer. Like, is there a correlation there or not? So you see, it's very important. You have to be very cautious with selecting words for your hypothesis. Then it comes to the tools that you're going to be using. And the tools that you're going to be using is a psychological tool, psychological test we call. In the psychological test that we call inventories. So or any other test that you will be using, you need to know about its reliability and validity. If those tests are not reliable and valid, your whole research will be unreliable and invalid. So you don't want that. So make sure you select a reliable and valid test. Variable that you choose, once again, you need to know the difference between these variables. The main two variables that you will be using in your research are independent variable, IV for short, and dependent variable, DV for short. One word definition that if you don't know, you must know by now that the IV is the variable that we manipulate, and DV is the variable that we measure. Very quick example I give you. If I tell you that we conducting research regarding the effect of hunger on learning. So this is experimental. We have two groups. And our variables are hunger and learning. And let's say we decide to have two groups of people, one of them well-fed, and then the other groups are hungry. And we give them some kind of mental task. At the end, we will, do the measurements, and we realize that the group that did let's say they were hungry, they did better. It doesn't matter in this case. Well, again, if somebody comes to you and say, hey, I didn't do well because I ate too much, or the opposite, because I was very hungry. But or something in this case, let's say temperature, for example. If they say, well, it was too hot or too cold, because we don't have that that variable. We have the IV and DV. But if they talk about something that we didn't measure, like temperature, somebody said it was too cold in that room, or it was too hot. So we say that we held the temperature as constant. That right there is a constant. Constant variable. That means all the rooms, both rooms, had same temperature. So if it was cold for you, it was cold for everybody. If it was hot for you, it was hot for everybody. So that would be a constant variable. And then a discrete variable are the whole numbers. Discrete numbers are whole number, 1, 2, 3, right? The discrete variable are, for example, like people. Like, you have 4 brothers, 2 sisters. Continuous number have fractions, 2.6, 3.5. Continuous variables, so for example, are volumes. Volume, weight, like, let's say you weigh 101 pound and 10 ounces, okay? Or my coffee, I have 2.6 ounces of coffee here, okay? So those are continuous variables or continuous numbers. Intervening variable and confounding variable are something that you can read. It helps you for your research. And I have them here. But again, this is not a research class. We don't want to waste time and explain those variables to you. But we're not going to have use for them in this class. So let's see. Okay. So let's continue. again, we're dealing with quantitative research. The role of statistics in quantitative research. You need to know the difference between descriptive and inferential statistics. We already talked about inferential statistics. It's all about number. It's about draw conclusion from your sample. Like correlation, you take a sample, let's say from Albizu University, and you want to see if there's a correlation between stress and depression, and it shows yes, there is positive. So you can infer or draw conclusion and to the population, not just, keep in mind, not just AU population, but to the world. Again, because they say correlational non-experimental research have a high external validity, and this was what it is external validity, inferential research. And we'll talk about this when the real measurement starts. But we need to stick with descriptive for now, which I call little guys. Get those descriptive out of the way, and then again in a few weeks we talk more. We start talking about inferential. Descriptive statistic, just like the name suggests, describe something. And like for example, over here, some example of descriptive research, if you'd like to know, give you some idea. They are scale of measurements. Like for example, if you want to know, for example, what's the average income for AU professors? All right, it's descriptive, describe something. What's the average height for AU doctoral students? All right. Frequency distribution, graphs, measure of central tendency, mean, median, mode, and measures of variability, standard deviation, variance, range. We're going to talk about all these this week and next week, and we get the descriptive statistics out of it. And there's some example, research example of research. This is the example of descriptive research. We use descriptive statistic for descriptive research, and inferential statistic for inferential research. Okay. There are three kinds of descriptive research: case study. It can be qualitative research, and survey using questionnaire can be quantitative or qualitative, and mixed observational study, which can be either one, quantitative, qualitative, or mixed. Briefly, inferential statistic, infer or draw conclusion from sample. That's what we talked about. And here the big guys, correlation, regression, t-test, ANOVA, ANCOVA, MANOVA, MANCOVA. They never stop. There's more and more coming. We talk about those big guys mostly in advanced stats next semester when you take the advanced statistics. That's another example. And then this is some example of, again, inferential statistic that we will cover as soon as we get the descriptive statistics out of the way. Let's briefly start with scale of measurements, scales of measurement. In order to remember them, the mnemonic to remember them is called noir. It's a French word. N-O-I-R means black. So N stands for nominal, O stands for ordinal, I interval and R ratio. Briefly, nominal are at the bottom of the barrel in terms of measurement. Some people believe they're not even the scale of measurement. They're like labels, name. But again, we have them. So they like, for example, even number, for example, number on jerseys, football player, basketball players, that's nominal, even though it's a number, but that's them. Like, I'm sure you know your favorite, the number of your favorite basketball player, football player, or other athletics. And they belong in their own category. So it's at the bottom. It's not really very good measure. In psychology, for example, we do use nominal scale because, again, name, like depression, you're depressed. That's nominal scale, okay? Now, the next one, when, for example, is ordinal. So again, we use this in psychology too, like in order, some kind of order. Like I said, if it's nominal, it's depressed. Okay, you're depressed, you're not depressed, okay. But again, here, you put some order now. We can say that somebody is severely depressed or moderately depressed or, mild depressed, mild, moderate, severe. So again, this is some kind of order, or order in the military order, ranking and all that. So that's what it's all about. And then the difference between interval and ratio, they're pretty much the same. They both have equal distance between the points, everything pretty much the same, except the 0 point. The 0 point for interval is arbitrary. Arbitrary means it's artificial. 0 means nothing, nada, zap, zero, zilch. So, but in, for example, thermometer, 0 temperature, it doesn't mean like there's no temperature, or 0 Fahrenheit, 0 Celsius. So for that, 0 means something. This is interval scale. In other words, that cup of coffee that I mentioned have a 2.5 ounce of coffee in it. Once I finish it to the last drop, then it's 0 coffee in it. Now that's volume. The volume is ratio. In physics, we use such a scale. Like for height, let's say you 5 foot 5.7, okay, right? And the volume, for example, right here, volume, height, and also age, weight, and time, and all that. All these are ratio. Some of them you can argue, but it's kind of tricky. But they are, if you think about it. So in general, if you put them together in this order and try to make sense, if you say somebody is tall, somebody's short, somebody's depressed, somebody's not depressed, all right, like I mentioned. Rachel is tall and George is short. That's labeling. That's nominal scale. You just, you're looking at them at the face value. Ordinal, you put them in order, like Rachel is taller. Okay, so we know Rachel is taller. Interval, you can tell that you have some kind of measurement. Rachel is 5 inches taller. But we still don't know, still don't see the big picture. In ratio, it tells us about it. it pinpoints that ratio is 5'10", 5 foot 10 inches, and Greg is 5'5". So you can see that how accurate ratio is. In psychology, we don't have such a scale ratio, unfortunately. So, and sometimes it doesn't even make sense, because again, you can have the scale to show zero stress. I mean, as the minute that we come to this world, you notice no babies will start crying because they stress. So everybody have a stress at some level. You cannot find a person with zero stress. Only a dead person has a zero stress. So you can see that some of that ratio scale is not even doable or in psychology. Again, you can see here that if you, right here at the bottom, it says that qualities of one level are characteristic of the next level. That means ratio is the best and also contain interval, ordinal, and nominal. Because if you look at the tool to measure the ratio scale, yes, this is a ratio scale also because it has a zero, absolute zero, because when it says zero, there's nothing else to measure. Also, they label all these numbers, could be individually labeled for something. Also, they in order, ordinal. Also, okay, so with that, it has everything else. It has the highest quality, and it has a quality of others, except that again the zero is absolute zero, is not artificial. That's the only difference. Now here's a little quiz for you. Test the scores are which scale of measurement? This is one of those hold on one second, get this straight. Okay. That I mentioned earlier that it's kind of confusing, but if you think about it, you will see that the answer for this one, anybody? Most people think it's ratio, but it's not. It's interval. Because if somebody gets zero on a test, it doesn't mean that they know nothing. Absolutely zero knowledge. It's just because they don't know the answer for that question, those questions.
Interval.
So let's see who's there. Celia is there. Hello, Celia. How are you?
Yes.
Did you get it?
Let me see. Okay. Share video. Okay. Let me see.
Yeah. This is one of them that is, You get a kind of mind twisting.
Domino.
Same as age. Most people think that age, for example, is 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 a ratio.
It's a rate? No, it's not ratio. No,
It is. It is ratio. I put
it
it there.
is.
Yeah.
Okay, okay,
Yeah.
okay.
Most people think age. Right there. Okay. Hold on 1 second. Let me go back. Mm, yeah. Age is a ratio. So, yeah. Most people think age is interval actually, but it's not. It's ratio. So these two are kind of mind twisting because again, the moment you come to this world, right? That's zero, absolute zero. Before that doesn't count. That's your age. All right. I'm glad you're there, Celia. Do you have any question?
Yes, I'm sorry that I came late, but I was in the doctor. I had a doctor appointment this afternoon.
No, it's okay. It's no problem. I understand. I mentioned that. So please review this. I'm recording it, so you
Yes,
can
yes,
always
I will.
watch it from the beginning. I understand because I've been teaching this for 20 years. So a
Yes.
lot of my students are professionals and they can. Doesn't matter. I mean, if it's, let's say, convenience for one student, it's not convenience for the another. So for
No,
that
no,
in mind, I
it was
record
a
my
coincidence.
session. Yeah.
Yes.
So and then so even but for in the future, I decided to just pre-record my sessions and just look at them. Whenever you have a time and. Let me know, please. Email me and let me know if you have any question, concern.
Okay,
Earlier,
thank
I
you.
went over the syllabus and explained that. So read it if you haven't, and let me know, okay, if you have
Yes,
any
I did.
questions.
I kind of went over the syllabus already, but still, if I have any questions, I'm gonna send you an email. But I usually do what I do is that I review the notes early in the morning because I work, during the daytime. So I
Yes,
get up
that's the
I get
good.
up really early and then I do the homework early.
That's good. That's a good practice. I like that. That's very good. This is not really a hard class at all. Like I said, if you just follow the syllabus, and but the thing is, it's a lot of work. I understand, and it's a serious class because again, this will prepare you, help you with your doctoral dissertation, and so. But again, if you stay on top of everything, you realize even if you were if you were away from the school for a long time, still you're going to find it that it's not difficult at all. And you will see, not just this one, but as a matter of fact, most of my students, they found this course, which is basic stats, much more difficult than advanced statistics that you're going to have in the next semester. Even though in advanced stats, we deal with more heavy duty um, statistics, but
Mm.
once we get into hypothesis testing, everything else is the same. It's just different statistic, but the hypothesis testing is going to be the same for every one of them. So you're going to see that there's some relief, like, oh, I know, what to expect and all that. Okay, well,
Okay.
we're going to cover. Thank you. We're going
Thank
to
you. Mhm.
let's just go briefly over these charts, so just become familiar with them, and then there are a couple of other descriptive statistics, and we call it for today. So as you can see, this one here, um, it's a bar graph, of course, you know, because there are a bunch of bars. This here deals with frequency distribution and graphs. So there are different types of graphs or charts. And the reason we use those in statistics and research because they contain a lot of information, good information. They explain so much. Like what you're looking at is that right there, almost 100 years, 100 years of research in, let's say, if you're a marine biologist, you notice that, you know, from 1900 to almost like 1990s and all that, the number of shark attacks increased. So if you're a marine biologist, you want to know what happened, why it is so. That little graph will explain all that. So that's the purpose of using these charts and graphs. Okay. And then this one, like I said, that one, because there's a space between the bars, it's called bar graph. This one, there's no space between the bars. So it's called histogram. No space, but it's pretty much the same thing. And then explain, like this one, it talks about that yellow warbird, again, that species, why it went down near extinction in 2002 and all that. And then again, this one, as you can see that we use for our scores in school. And actually this here, if you follow those bars, this is histogram. But again, this is something we use in school, especially in undergrad. It tells us, for example, like by just looking at it, instead of look at a bunch of numbers, you can see that light green, 90, most people got 80s and 90s. And then again, you can see exactly like 5 people got hundreds. But then you can see that the number of people who failed in the class. So use histogram, not bar. They pretty much alike. And this is also called negatively skewed. Normal distribution is symmetrical, is bell-shaped. But let me show you something. Draw. If I connect these together, you'll see something like this. It'll be something like this, like that. So you'll see a tail here. There's a tail compared to just normal bell shape. And then from here, it sharply goes down. Like that. So you see, that's not normal because the tail is on the left. It's called negatively skewed. And then again, if the tail is on the right, we'll get to it in a second. But that's how you can tell that, you know, what's going on. That kind of tells us easy exam because majority passed. We use these in like high school and undergrad, but not for doctoral students. Everybody should pass because they are serious and they know why they're here. So again, here's another quiz for you. It says frequency distribution of test score are frequently illustrated by which kind of graph? Any idea?
But a bar graph?
You're close. It could be, but really the answer is histogram. You can use a bar graph too, but this is more appropriate to use histogram. And then we have the polygon. Poly means many. So we use this kind of graph when, let's say, you compare the AU students with FIU, with University of Miami, and it tells us, let's say, if the green one is the, let me just do something. Okay, is the AU student, the green one, so you can see they excel, they score highest compared to others. And then we have pie graph, as you can see, describe different provinces of Canada in terms of population. And again, this is the one we use the most, normal distribution or bell-shaped, which is symmetrical. And then we already talked about this, I showed to you. And you can see that right in the middle is the mean. If it's symmetrical, right in the middle, you have the mean, median, and the mode. But once it's skewed to the left or right, which I'm going to show you, then you see those measures of central tendency are going to open. You're going to see them in order. It's coming in a second. And then that's, again, same thing in terms of measurement. Right there, the middle, almost 50% of population are in the middle, let's say in terms of IQ. So right there, the double-headed arrow, most people have average IQ. IQ average is 100. So one standard deviation of 15 point above or below is still average. It still is high average, low average. So back to this, you'll see that majority of people are average. And then you have high average, and then extremely high average, and then low average and extremely low average. Yeah. So again, back to that negatively skewed, as you can see, the red one in the middle is bell-shaped or normal distribution. But when the tail, like the green one, the tail is on the left side, then it's negatively skewed. But if the tail is on the right, it's positively skewed. Yeah. And then again, these are the measures of central tendency. At the bottom, the negatively skewed. When you open up the normal distribution, push it, then you see that in the middle, you have the median, the green one. The median is in the middle. And then the mode is the top, the bump mode, number of frequencies are highest when you see the mode. And then again, the blue is the mean from either side. And then there are other distributions with like two modes, which we call, for different research, like call it bi means two, bimodal, two modes. Like for males and females, there's some kind of distribution, just to become familiar with them. And then, but again, that shape of a bell shape, I have to stay in that position. If it goes flat or, changes, then it won't be the same. If it changes, then it has a different name. For example, you can see like green one is normal distribution. But if it's blue, see how flat it gets? That has a name. It's called platykurtic. Or if it's like pointed, it's called leptokurtic. And something in between is mesokurtic. And again, it's just to become familiar that green is the normal distribution. It has to be shaped like that, not like platykurtic. That's not normal. But again, that's just for information. It's nothing to be tested about. It's good to know that. And okay, so in here you're gonna know that we're gonna, in the future next week, we're gonna talk about degrees of freedom, or DF. Degrees of freedom is related to sample size. That's something that you need to know for your research. The higher your sample size, the better, because it's better representative of population. Just think about it. If you conduct research at AU, and if you have only like, well, first of all, if you have less than 30 participants, your research is not valid unless you use a special type of research, and we talk about that. But if you use, let's say 50, and I conduct the same research with 500 students at AU, of course, mine has more power. Power means power to reject the null. Remember, null always say, "Oh, I don't think so. You're incorrect." But if you want your research to have more power to reject the null, you gotta have more people, more participants, large sample, and this will shows that in terms of just the degrees of freedom, as it tells you, if your number of, if DF formula is n minus 1. So whatever your sample size is, you take away 1, and that's your DF. We'll talk about this. Right now I'm just showing the graphs and all that. Okay. Any question? If not, we're going to cover measures of central tendency, mean, median, mode briefly, because I'm sure everybody knows them. But again, we cover them. Measures of central tendency are mean, median, and mode. We already mentioned something that mean is the best because it's the most accurate one. And also we use interval and ratio scale. And in terms of charts or graphs, we use polygon for the mean. And how do you calculate the mean? When you got a bunch of numbers, let's say X in statistics means number of score. The difference between statistics and mathematics is, in a statistic, we have symbol for everything. Like a score, number of scores, for example, we use X. Like instead of plus sign, we use sum, like Greek, like a symbol, like a 3, inverted 3. E, sum of X means you add them up. So sum of X is 40. So that's the language of SPSS that everybody should learn quickly. And then in your quiz one, you will get some number like this, right? And then it says, what is sum of X? So you add them up. And then it says, what is sum of X squared? That means you square your numbers and then add them up. So you square the 7 is 49, square the 10, 100, square the 9, square 6, square the 8. Sum of X squared will be 330. So you know. Your quiz one consists of just how to measure, just very simple, how to do mean, calculate the mean, calculate the X squared, and then median, mode, and all that. So if you get a bunch of numbers, you add them up, divided by the total number. Okay? So, and there is a difference between sum of X squared and the square the sum of x. The red one, let's have you read them. I know. That's why I wrote this down. If it says, what is the square of the sum of x? The red. You see that? Sum of x is 40. So what is the square of sum of x? That means you square the sum of x. 40 times 40, 1600. But if it says what is sum of x squared, then you need to square each x. X is the score. And then add them up. That really, you guys pay attention there, so you make sure. By the way, I think I mentioned that you have 2 trials when you take your quizzes. You take it once. If you're not happy with your grade, take it again. And Blackboard, we select the highest score. And then again, I know there's always a technical problem. Let me know if there is some kind of technical problem, needs to be reset or something. That's important. So don't become frustrated. Anyway, so this is how you do it. You add up the number divided by total numbers. We have 5 numbers. We add them up. That's the mean. And this characteristic of mean, just in general, whatever you do, the mean will be this. The mean will change. Like if you change any of these numbers, the mean will change, except if you add another number, which is same as mean, which is 8. So if you add another 8 and another 8 and another 8, still your mean will be the 8. That's what these are saying. But anything else will change it. Then we have the median. Again, what's the definition? The middle number. If I give you a bunch of numbers, you say, what's the median? You select the middle number. However, you should know that median goes with the ordinal scale. An ordinal, that means you got to put them in order first. So if I give you those numbers at the bottom, it says 7, 12, 24, 20, 19. First thing you do, you put them in order, right? 7, 12, 19, 20, 24. And what's the median? The middle. That is if they odd. If they even, then like there's 5 numbers, that's odd. If you add another number, then you go for the 2 in the middle. You add them up, divide them by the 2. And the mode, like I mentioned earlier, is the most frequently occurring score. And that goes by nominal scale. Like, for example, I have some graphs to show you in a second. Let's say you work for Starbucks and you see a graph, bar graph or histogram. It shows that the number of latte are 10 million for the last month. That's the frequency of that latte. So nominal scale, mode goes with goes with nominal scale, and we use it in bar or histogram, and I will show you that again. It's the most frequently scored. Like if you, in terms of number, if you see those number at the bottom, which is the mode, the number that repeated itself the most. You got 218, 119, 3 20s, 121, 123. So it's pretty obvious that the mode is 20. And again, whether it's the number or it's the object. In terms of object, like I said, you will see that. You see the same bar, but with different, let's say, name. Whether it's shoe brands, whether different coffee and all that. In terms of characteristic of the mode, Again, we already talked about these. Use nominal scale and discrete variable, and it has a describing shape. I'll show you those shapes. Then compare them where we have that. So your quiz one consists of questions like this, like to calculate the mean, a median, and the mode for like these numbers. That makes a good practice. And if you do this and send them to me, that's how I know you guys did something, doing something, because I would never know who see, who doesn't, and unless I, see your score on your quiz and exams. But if you do these things, I know that you're doing something that if you need extra point, this here will help you. You get that extra point. I explained that earlier today. In terms of frequency distribution, that's another descriptive statistics. We use this when we have many scores. So if we have a sea of scores, many millions, even though here in my example I only have 14, but again I couldn't put 14 million. It doesn't matter. The idea is when you have a bunch of numbers, there is a way to organize them, which is called frequency distribution. By instead of write them down, let's say right here we have 2, right? 2, 2, 3, 2, 4, 2, 4 twos. So let's say we have 4 million twos. It doesn't matter. You write 2, and then 2 is the score. So under the X, you write 2. And then F is the frequency of the 2, which is, in this case, will be 4. Or if it's 4 million, you put 4 million. So you create a table like this, with X being the score, in this case 2, frequency of it 4. Fx means 2 means F times X, 2 times 4, 4 times 2, same thing. There's 2 other things we're going to do, and that is this P. This P stands a symbol for proportion. And then we have 2 different distributions. One is called proportion, the other one's called probability. Probability is always 100, from 0 to 100. Let's say, what's the probability that you pass this course with A? You might say, it depends on your self-esteem. If you have really good self-esteem, you will say 100. Somebody say, well, 95, 90, or even somebody say less. So, but you can't go over 100, even though people go, 110, but that's just figure of speech. So the scale of measurement for probability is 0 to 100. On the same token, for proportion, it's from 0 to 1. So the highest you can get is 1. Like, for example, if you say 50%, that in proportion, that's probability, percentage. That would be 0.5 in proportion. If you say 90%, that's 0.9. The way to convert these two is to, right here, right there on the right side of the screen, this says proportion from 0 to 1, probability from 0 to 100%. So if you wanted to convert, if a number is, let's say 90, how do you convert it to proportion? Divided by 100, it will be 0.9. On the same token, if a number is in proportion, let's say is 0.6, converted to probability or percentage, you multiply it by 100, which will be 60%. You need that because we're gonna, in the future, in the weeks ahead, we're gonna use some tables on back of your book, and they are in proportion. Sometimes we need to convert them to percentage or probability. That's when we cover the chapter probability. So again, back to this frequency distribution, once you, in order to calculate the proportion, frequency, which is, let's say for 2 was 4, and divided by n, which is the total number of the score, were 14. All right? So 2 divided by 14 is 0.14. That would be the proportion for 2. I mean, for 1, this is, sorry, this is for 1. For 2 will be 4 divided by 14. All right? Remember, all those numbers, x, we had 1, we had 2, we have 3. So we said that there are 4 2's, and 4 times 2, fx will be 8. And the proportion of it, the proportion of 2 will be 4 divided by 14, because there are 14 numbers. Right here, there are 14 numbers. And you can see that we have 4, 2, 2, 1, and so on. We put them in that table. And over here, back to that table, right here. So stick with 2, x is 2. Once you calculated your proportion, in order to convert it to probability or percentage, multiply it by 100. That would be 29%. And then the last column is called cumulative 100%. Cumulative means adds up. So you add it up with the next one. You add that number, 29%, with the previous one, which is 14%. That gives you a cumulative number of 43%. So I did all of them for you. You can just look at them. For example, 1, x is 1 here. We have, x means the score. We have the score, 1. There's 2 of them. So we come here and we say the score is 1, the frequency is 2. So fx will be 2 times 1, which is 2. The proportion will be 2 divided by total number of scores. There are 14 scores. 2 divided by 14 is 0.14. And the percentage, 0.14, will be times 100, 14%. And since there is no number before that, this is our first number, the cumulative number will be 14%. So again, you can see them, look at them, and get some idea. And that's just to show you why do we have that. Our number were 1, 2, 3, 4, 5, 6. So if you look at them right here. Yeah, again, we have 14 numbers, but if you look at them, they are 1, 2, 1, 4, 2, 3, 3, and 2, 4, and 2, 5, and 1, 6. That's what they are. There is no other number, 7, 8, 9. If you have a bunch of numbers like that, and you've been asked to calculate what is the mean. Mean, by the way, this symbol, mu, the one that says like a U, that's me, you. That's a Greek symbol, mu. And is equal to sum of fx divided by sum of f. Sum of f is mean for frequency distribution. Okay, so sum of fx divided by sum of f. So if you wonder why do we have fx, because we need the sum of fx. You add them up, okay? Sum of fx, 2 plus 8 plus 9 plus 8 plus 10 plus 18, sum of fx, divided by the total numbers, which is the 14. Also, it says here, the total number, n, total number of participants. These symbols, there is a copy of the symbols in your syllabus that is good to learn the symbols, because statistic has its own language. And like I said, sample n, small n is a sample for sample size. So sum of f is really 14. Sum of the frequencies is 14. If you count these, is the same. That's total number of scores. Okay, and then P is F divided by N, frequency divided by N, and then proportion and all that. So that's how you do those. Sum of Fx divided by sum of, so again, if you have this number, this is how you calculate it. This example that I just went over. If you can look at these, you have access to this PowerPoint, or you can watch this video again, and you will, sometimes it's hard first time to get it, but there are other distribution. There's one more that we use, standard, for a standardized score from 1 to 100 in terms of height, weight, and the standard unit, like for z-score that we're going to talk about in a few weeks, has a standard deviation of 1, like what you see here. Like a standard z-score is a standard score. IQ is a standard score. Standard means stay the same, always. It doesn't change. Like IQ, standardized IQ tests that we use, they all have a standard deviation of 15, but this is z-score. Z-score has a standard deviation of 1, but we will talk about this later in a few weeks. But this to show you that the number at the bottom, this is a distribution. But this next topic is called stem and leaf displays. We don't use this really. It's not very popular nowadays. It was popular in like 70s and 80s. It's another way to do the frequency distributions. Like when you have a large numbers, how do you put them or group them? It's called stem and leaf. I color code them so you can see the difference. Like the red, like 23, the 20 is called leading digit. And the trailing digit is 3 leaves, okay? So when you see numbers like this, like the data, okay, this is a distribution. Like you have a large numbers. These are not too many. You got 7 numbers. Well, you have a lot of them. Like that latte that I was telling you about, you got 70 million latte you sold. So you can't just put latte, 1, 1, 1, 2, 2, 2, 2, 3. You repeat those numbers. Okay, so you just show that with a histogram, and then you write 70 million. At the bottom is measurement. I'll show you in a second. It's coming. It's right there. So this is the same thing from Starbucks. And if you the CEO of a Starbucks and you want to see what's going on, who's buying what, you will see that At the bottom is dollar scale. You'll see that over million, that's $11 million sold of latte. And espresso, like for example, the orange next to it. This is in reality, that's how it looks. This is stem and leaves. In terms of numbers, it's the same thing. These are the numbers. This is also like a bar graph or histogram. It's the same thing. But the way we read it with number, which is not popular, this was created really before this high power statistics and the software that we had. This is how they would deal with them. It's just like a history where we're talking now. And so if you have a number like 23, your stem will be 2 and your leaf will be 3. And then, what other number? You have 5, 58, so the stem is 5, 8. But if you got like bunch of 60 numbers, so 60, so 6 is your stem, and then again, how many 62 you have? 2, so you write 2, 2, and then you have 3, so you add the 3 and 5 and 6. This is how you read them, and that's how it looks like. You should be able to read these numbers: 22, 23, 25, 25, 29, right? 31, 32, 32, 30, and again 42, 40. Stem and leaf. SPSS, the good thing about SPSS is it will do this for you. You put millions of numbers and ask, create a stem and leaf for me, and bam, you will see it. And I'm gonna show you. I already done it, and I'll show you. And then it said, with the purpose of this, why they use it? What's the usefulness of this stem and leaf? For research and different type of research, different purposes, can be useful for comparing two different distributions, such as comparing scores from men to women and all that. So again, but if you have many numbers, like 50s and all that, same thing. You can break it down, like you have too many 50s here. So you can break it down from 50 to 54 at the bottom, and then 55 to 59. You can do that. You don't do this manually at all. This is like when you do the SPSS, you be able to read it, or you get a job and it shows you stem and leaf plot or stem plot. You should be able to read it. That's all it is.
And what's the order? The order goes from the highest to the lower.
It doesn't matter. You can do it either way. You can go from lowest to highest. That's a good point. But again, I got something. I just thought to share this with you. That's a good point. I would do this. I would do though, Celia, and you're right. But it really doesn't matter. Let's say the guy who did this, he decided to go the other way. That's all right. So yeah, you're right. It should be that way, but it's not. But anyway, guys, in terms of IBM SPSS, I said this earlier. It's very important. It's free for you. All you have to do, contact IT. You can talk to Rudy or Louis, or email them, and just IT, and let them know you're taking this class, and you need to have a copy of SPSS. Usually it's good for a year. My copy even expired. I just wrote them, emailed them today, and I told them that I need to get a new copy. So what they do, they send me a link or send you a link and the instruction how to download that into your laptop. So it's really easy to do so. Once you got it, then you'll see something like this. What you see, this is the older version. I think the 28 or 29 is out. So this is the symbol for IBM SPSS. You click on it, it opens up. So there'll be extra um, windows. Just close those, all the windows. Once we get to this, if you have a Apple computer, you see that at the bottom left, it says variable view and data view in blue and orange or yellow. Apple computer have that in the middle. So, you know, it doesn't matter whether it's in the middle or is on the left. First thing you do, you click on variable view right there, which is yellow at the bottom. So variable is name. It's the name your variable. This is for research. We use this for heavy duty, but from this small calculation, our variable is just a, you can call it score, or you can just put X. I put scores or score, or you can put just X. X means score or scores. So that's you name. That's the name of your variable. Okay. Then you click on data view. Once you click on data view, you put a bunch of numbers like these numbers that you see. And now, okay, what do we want it to do? It's always the same, by the way. You name your variables, and then you go to data and you type in. Right there, you see the score, where score, scores, or X. Type in the number in that column. And on the left, the blue column, 1, 2, 3, those are number of your score. And I can tell I have 10 score. And keep in mind, score come from people. So I have 10 people, and those are their scores from whatever I got them from. Now, always go to, okay, hold on. Okay. Always go to analyze. It's always the same. The sooner you learn this, the sooner you become master of it. Click on analyze, like highlighted, yellow, and then descriptive statistics. That's what we're talking now. Descriptive statistics. And then it says explore. Click on it. Click on the explore and you will see something like this. And all keep in mind, all these numbers, they all attach to that one variable or name, which is called, we call it score or scores or just X. It's here. Let me just use this so you can see it. It's going to be here. It says score right here. All right. So what you do, you either drag or paste it to the right there. Or you can highlight it, click on it, and click on this arrow, and we'll transfer it to the right. You can just play with it, and you get used to it. So one way or another, you just highlight it or just drag and paste it and put it where it says dependent list. And then what do we want to do? Click on plot. And then we want it to do right there. When you click on plot, that window will open. And you see where it says stem and leaf. Stem and leaf. Click on that. And that's it. Then you click on continue and then click on OK, and it's done for you. And you will see something like this, plus. You see that? So those are your frequencies. This is your stems, and so it tells you that 30s were, okay, stem. Those numbers were, there were 3 numbers in 20s, 21, 22, 26, and 3 numbers in 30s, 35, 35, 37, and so on. 3 numbers in 40s, right? 45, 47, 49, and then one number in 50s. So you can do this. Like I said, this is how you read them. You're not going to do this manually or anything. It's put the number there, click on stem and leaf will do it. And you see this at the bottom, you see a box plot. That's what they call it. It tells you you can see the bottom of it. It says the top number, the handle, it gives you the highest number, and there's another like an inverted T at the bottom. It gives you the lowest number and then the middle numbers. Explain it for you. In terms of other one, those numbers that we did, frequency distribution, again, you're not going to do this manually at all. You know, it's ridiculous. And keep in mind, in reality, guys, you're not going to do anything manually, any calculation manually. We know that. But the whole purpose of taking this class and the next one, advanced stats, is to become familiar, understand the difference between these statistical procedures. Not just these little guys, but the big guys. You know, correlation, regression, you know, multiple regression, different type of t-test, different type of z-score, different type of ANOVA, one-way, two-way, three-way ANOVA. Man, you need to understand the difference between, but not really the calculation, but the calculation will help you. It teaches you to, that's the difference. You will know what I'm talking about once you're done with this course. And so you can use your knowledge and apply it to your research, to your doctoral dissertation, and select the right statistics for your research. So remember these numbers, the 14 numbers for frequency distribution? Same thing. You go, you open your SPSS, and you click X score or data. You can write data. You go, okay, always the same. At the bottom left, click variable view. That's how you name your variable. Or name it whatever you want to. Either X, either score, or data. Now this time I call it data. And I typed in those numbers. Bam, here they are, the same numbers. Now, same thing. You go to, again, now keep in mind, I back up a little. You start with variable view, right? You type in your variable, whatever you name it, data in this case, or X or score. Then you click on, at the bottom left, it says data view. Okay, you click on that because you want to work with, type in or input your data. You'll see that word data, that variable on top. And then you type in your data like I did. You see those numbers? I typed them in. And you type in yours. And then again, same thing. You always go to analyze. You always go, in this case, descriptive. As long as we do descriptive research, you click on descriptive stats. And then this time we're going to do frequency. So you click on frequency. And when you do that, same thing. You will see right here, it says data. All those numbers, all 14 numbers, are attached to the word data. It says right there in that red circle I draw. So what you do, you drag and paste it to the right space, which it says variable. Like I did, it says data in there. Then you click on statistics, and then this window will open, the other one on the right. And then what do you want to do now? You can do the mean, remember? Mean, median, mode. You can do the frequencies right there. Except remember, when it says percentile, like how often you put 10, put number 10. And then right there, when I circled it in blue, if you click on it, that number 10 will come down, and it is down now. And then at the bottom, you click on continue and go click on OK, and you're done. Voila. And you will see that, oh, okay. So another thing is, if you click on, it has a lot of things. Right there when it says chart, it's hard to see. Yeah, charts. If you click on charts now, then it gives you an option to select the chart, and you can select bar or the histogram or pie. So I selected, that's all you have to do. Just click on charts, and then you see a list of different charts. And click on any of them that you want. I clicked on pie, and this is what I got. And this here, you can see that the frequency distribution, like you can see, extremely accurate. It says that everything, you know, like the frequency of 1 was 2, frequency of 2 is 4. That same table that we did, only is much more accurate, because it also tells us the percentage to the fraction and also cumulative percentage. It's much more accurate. So this is really what you need to learn. In reality, this is what you're going to be used at your work for your research and all that, not manually. So it's all about understanding. And like I said, it's hard to understand all these. Maybe it's too much, especially if you were out of school for a long time or you have a very busy life. But watch it again. I record it, and it's going to stay. And I will try to put it in YouTube and have a link and put it there so you can use that link too. But now you should be able to do your quiz 1 and do your first SPSS. There's no like exact deadline for this, but the sooner you do it, the better. But definitely you must do all the quizzes and the SPSS assignments before you take the midterm exam, which is coming like about 7 weeks, 8 weeks or so. So it's good to stay on top so we can just move together forward. All right, Celia, Miss Celia, do you have any questions?
No, I'm going to review everything tomorrow morning. And if I have any question, then I'm going to.
Oh, okay. Well, I hope you're not scared.
No, I'm not. I'm not. I'm kind of long time ago. I took a statistics class. You know, when we didn't have computers like now, so I did a lot of little numbers. But you know, I had to review everything over.
Yeah. Yeah, it's just statistics really is not hard, but it has a bad nature. The nature is, Celia,
it's kind of scary because it's a lot of numbers and graphics, but it's
and the thing is, if you don't constantly look at the materials, you forget. I forget.
Yes.
It's not something that stick to your brain like a riding bicycle forever. No. You forget. I guarantee if you don't look at anything, if next week I go over same stuff.
Yes, I do have some knowledge. When I was in college, I took introduction, and then I took a class later on. But you know, it was many years ago. It was like more than 20 years ago when we didn't have these computer things and all that. But you know, I'm gonna try my best.
Yeah, well, that's good. Well, it's a refresher for you. It comes back to you. But again, please let me know if you have any question, any concern, any, you know, anything, let me know. Email me and let me know. That's why I'm here to help you.
All right. All
Other
right.
than that, have a great night.
You too.
And like I said, I'm gonna record my next session. So you know, to be more convenient for you guys, you don't have to be here, you know, at the right time and all that. And I'm gonna number them, number 1, number 2, 3 in order, and you have access to them all the time. So please watch them once, twice, as many times as you can. And if you don't understand anything I said, let me know.
Okay, I will. Thank you very much.
Thank you. You have a good night. Bye-bye. Thanks
You too.
again for
Bye-bye.
attending. Bye.